Hello and welcome to this video taking you through how to do this 3-pen self-marking method. It's an effective way to help you reflect on your work and improve your technique when answering exam questions either under test conditions or as homework. So obviously you can use any 3 separate colours, but I'm going to use black, red and blue for the purposes of the explanation in this video. So my first goal will be in black, not necessarily under time conditions. So this will identify what I feel confident about and what I'm less sure of. So, using my notes and textbook now, but not yet looking at the mark scheme, I switch my colours around and I annotate and I add things to my answers. So this identifies what I can work out with some help and prompting, but it isn't yet secure in my long-term memory because I had to look at a book in order to work it out. So finally switching to red, I make final corrections using the mark scheme. Hopefully there won't be very many of these, but the ones that I find, these will be the ones that I struggled with, even if I have the textbook and notes in front of me. So this tells me that they're urgently in need of support from somebody else. So a teacher, for example, you might need to go and see somebody or email your teacher to ask about this. So let's try it out on a question to see what it will look like in action. So, I chose to make this video clip on purpose towards the end of a lesson, so I sat in a side room when the lesson was going on, just to illustrate how important it is to make sure that when you do your revision, you're not being disturbed and you're not being distracted. So now that the lesson's finished, we're into lunchtime. It's a bit quieter, isn't it? So what I can do now is use this time to go through the question. So a little bit of a deliberate background noise there in the first minute of the video. So my first attempt is going to be in black with no help. I'm not looking at the time at this point, so I'm just going to run through it. It may take a full 6 minutes because you can probably see it's 2 marks for the first part and 4 marks for the second part. It may take more time, it might take less, I don't know. I'm not going to pay attention to that because I'm just thinking about what do I know. So I'm going to highlight what I think is important as I read through the question. So I'm going to put myself in the mind of a student, and you'll probably disagree with some of my first answers. That's the whole point, so you can see the actual improvement process happen as you change colours. So the first thing says, predict with an equation what reaction takes place when strontium is exposed to air. Now I'm thinking that because strontium is a +2 element, in other words it's in group 2, and oxygen forms -2 ions, that they're going to react in a 1:1 mole ratio. So I've already worked out that exposed to air means there's oxygen. So I'm going to react my strontium with oxygen to make strontium oxide. So going on to the second one, it says the reaction of strontium with water is a redox reaction. So I'm remembering doing redox in class, so I've noticed that it asks me to do oxidation numbers to show that strontium has been oxidized in this reaction. So remembering what my teacher showed me on how to work it out, I've assigned oxidation numbers to everything, and I've worked out that strontium has been oxidized because it's increased its oxidation number from 0 to +2, and hydrogen has been reduced because its oxidation number is +2, because there's 2 hydrogens in water, so it must be +2 and not +1. But +2 going down to 0 is a reduction. Now I can go and have a look at how many moles of strontium were reacted. So it gives me the molar mass of strontium is 87.6 grams per mole. So doing moles equals mass over molar mass, my calculator says 1/200. So I'm going to convert that to a standard form. I'm going to put that in the answer line. So now I'm feeling quite chuffed with myself because not only have I remembered to convert a fraction into standard form like I've been told, but I've also remembered to put my answer in the answer line. So things are going well. So the concentration in moles per decimeter -3 of the strontium hydroxide produced. So remembering that the number of moles is concentration times volume from my work that I've been doing on titrations whilst I've been learning about acids and redox, I can put in the numbers now. So to do this, I need to know how many moles of strontium hydroxide are produced. And looking at the calculation of how many moles of strontium are reacted, it makes sense that because the strontium to strontium hydroxide mole ratio in the equation is 1 to 1, you'd also have 5.0 times 10 to the minus 3 moles of strontium. So looking at the question, I can see that there's 200 centimetres cubed of water mentioned. It says a student reacted 0.438 grams of strontium with 200 centimetres cubed of water. So I've attached the relevant pieces of data to the parts of the equation that I've just written out. It's clear that what they want is the concentration, so now I have to rearrange. So dividing my number of moles I've just worked out by 200, which is my volume, I get 2.5 times 10 to the minus 5. Now, that took me just under 6 minutes, so I'm also feeling quite pleased with myself that I did it without any help and I did it within the 6 minutes I'd allocate, because it's a 6-mark question in total. So now I'm going to switch to blue and I'm going to go back over my answers with the benefit of my notes next to me. And in the first question I realised that the oxygen should be O2. So now I can work out where I've gone wrong. Now I might not have spotted that first time, obviously I didn't. So by going through it a second time, I can now recognise with a bit of prompting that I needed to balance my equation by making sure that my oxygen in the air is O2. Going a bit further down, I'm happy that my uncombined elements are 0, so I'm going to tick them. But I've now gone and had a look at my hydrogen, which I've claimed is +2. From my oxidation number rules, from my textbook and my notes, I now remember that each individual hydrogen atom is +1. So I'm going to change that to +1. Now my oxygens are -2s, which they should be. My strontium ends up as +2 because it's a group 2 element, so that's fine. But the funny thing is, I actually thought of the hydrogen being +1 in the hydroxide ion. So I'm going to just put a reminder to myself to read the question there, because I got it right in the second part of the equation, but got it wrong in the first, so I was being a bit silly, wasn't I? Now, in the third part, where it's asked me to calculate how many moles of strontium are reacted, I'm using moles equals mass over molar mass, so although that's good. I remember to change my fraction that my calculator gave me into a standard form, so that's all good. Now, in the final part, it says calculate the concentration in moles per decimeter to the -3. Now, so far so good. It's all fine for the moles. Concentration is N over V. I think I'm alright with that actually, so I'm going to leave that one. Now what I'm going to do is switch to red and bring up the mark scheme. So give me 2 seconds to just pull this up. I'm going to put it on the right hand side of the screen here. So looking through the first question, you can see that I've got the equation, but I didn't read the question properly because it told me to predict with an equation what reaction takes place. So one of the answers was to say strontium oxide is formed or strontium reacts with oxygen. So I'm afraid there's a cross there. In the next one, my correction is fine, but you can see the way that they've written the answer. It says in strontium oxidation number equals 0, in strontium hydroxide oxidation number is +2. Now, this is a tricky one because I've done the working, but I haven't really written it out in words. So because it doesn't really match what the exam mark scheme says, but there are elements of it that are correct, I'm going to take that to my teacher and I'm going to check with them to see if they'd agree with me on that. Going on to the third one, the number of moles of strontium that were reacted, it says 5 times 10 to the -3. So that gets me the mark. And the bottom one, it says 0.0 0.05, which is what I've got, times 1000 over 200. Now, what I didn't do is this. I didn't convert my centimetres cubed to decimeters cubed by dividing them by 1000. So this one is actually wrong. So now what I can do is make a list of things that I've got wrong, and I can now have one technique target, so reading the question to make sure I don't miss something out. I need to practice moles and solutions, unit conversions. I need to go and get my Redox answer layout checked with a teacher to make sure that I'm answering it in the way that it's going to get the marks from the exam. So switching back to my sort of teacher mode now, hopefully what this has shown you is how 3 different colours have 3 slightly different mindsets. And in each colour you look at the question a slightly different way. And as you do so you catch yourself making mistakes. And that teaches you what not to do in future. And it reinforces what you got first time round. So for example, I can see that this student fully understands how to calculate the number of moles of something from its mass. They're a little bit shaky on oxidation number layout. They need to read the question, they were a bit sloppy at the beginning, and they need to go and learn how to do moles and solutions calculations by converting their volumes from centimetres cubed into decimeters cubed. So if they had shown me this piece of work with all this annotation on it, that then tells me they've gone away and tried it, thought about it, reflected on what they've done, and come up with some of the answers to improve it themselves. It takes their own learning further and makes them more independent and more effective and more confident when they sit their next test. Okay, so thanks for listening. For now, hopefully it gives you a few ideas about how to do this with your own revision. And until next time, see you soon.